Today, we'll be covering about microservices, basically microservices in system design. And this is today in-depth session about microservices and various architectural approach for building scalable and very reliable systems applications. Great. So let's begin the session. Today's class is on microservices. Okay. So let's start today's session, which is about microservices, right? So you would have heard this term a lot, but no, today we will be covering it in detail, when to use it, how to use it. So before that, I will take a look into what is monolithic. So basically there is something called monolithic architecture. Anyone, what is monolithic architecture? What do you know?
Monolithic is like a standalone system where all that particular application is running on a standalone system only.
Yes, right. See, you exactly know, need not have to be standalone. What is important is you have all, see, basically there is I will again tell one more type of architecture, right? Before this, let's talk about, there is something called modular architecture, right? What is modular architecture? Or this was more component-based architecture, right? See, in the older days also, you would have heard about distributed applications, right? Distributed applications, there were RMI earlier in various technologies, code bar, but yes, they need not have to be standalone standalone systems. What is important here is, see, any software, any complex piece of software. So if I have any complex piece of software, let's say I have an application. Today we'll use this example, which is e-commerce application, because this is a simple application. Everyone understands what is e-commerce application, and we'll give examples using e-commerce application, right? So what actually happens now, if I have to design an e-commerce application, what I can do is I can say there is client, right? This is my mobile, right? So I have a mobile client. Then I would have various modules, right? So I am designing using modular architecture. So that is, so modules are nothing but they are also components, right? So modules or components, they are the same thing, similar stuff. Slight differences there in modules and components also. But yes, for us, we should understand that there would be various custom components. So customer service, that could be one component. We may have a component which we can say product catalog, right? Here, what you will do, you will, in an e-commerce application, you can search for products, right? So let me put here, this is at the end. Next, what you will have a shopping cart, right? So shopping cart, there would be many modules, but we'll give some, we'll take some few examples, a few components. Will not take more many components. Now, these are modules, right? So customer service is another module. We may have other module also, which could be, last time we discussed about payment gateway, right? So there could be, say, a payment processing service, right? So payment service, let's call this payment service. This is taking care of the payments, right? These are various services. Maybe more services are there, which could be warehouse service, which could be logistics, and so on. So let me denote this with ... right? So I'll put 3 dots. right? So multiple dots here. This denotes that we have many components. Now, if all of them are deployed together, right? This makes it a monolithic architecture. So basically what you have is you have all the components deployed together, and definitely these components will also be talking to some database. Where is the database? Let me take this here. So I got this database. So here, if you see, this is a classic monolithical architecture. Okay, let me write here database also. So this is how all the traditional applications were designed, right? So basically what you have is you have here a single code base, or there is a deployment unit, and there could be multiple deployment units. There could be multiple EXEs or jars or various components which would be there. But yes, everything sits together and they are tightly integrated, right? So this is tightly integrated. That means these systems, these components, they can call each other, and they call each other like local services, right? So let me say this product catalog will be talking to shopping cart would be talking, and there will be various interconnections, right? So let's say here again, another interconnections there. So you have a lot of components interacting with each other. This is what we call tightly coupled. Yes. Or tightly coupled is nothing but tightly integrated. That means you need to know the function names. You need to know the signature of the function. What are the parameters, input as well as output parameters? And when you call it, you are calling the functions and appropriate parameters to make call to different services. Yes, very efficient architecture. It will be very fast because everything is together, right? So this is what is monolithic architecture, right? So this is what is monolithic architecture. So here basically all modules are tightly integrated, okay, into a single code base, right? Or you can say deployment, yes, unit or server, or yes. So this is everything together is about monolithic architecture.
And I think their databases are also, database is also a
Yes.
single unit.
Perfect. Yes, absolutely right. Nice point. Here, if you see, this is the client. There could be multiple clients, and database. Database is single. Here, everyone is sharing the data, right? Sharing the same instance of database. This architecture is very easy to start because you need one server. You can very easily create a development environment. So with this architecture, you can have a simple structure and all components can interact, and all components can interact also fast, right? And then other thing is that it is easy to build and deploy, right? So this is basically easy to build and deploy, and that means everything is together. You need one server, you can deploy. And then the problem, there could be some problems with this, right? So as the application grows, say assume this becomes bigger application, you will have here teams, right? So let me change this to teams. It's not users, let's say teams, right? Teams means dev teams, to be more particular about. You will have one team working on, say, product catalog, right? You'll have another team. So here, yeah, let me say this. There could be another team. So you would have basically different teams working on different components, right? And so on. So payment service, customer service, etc. What may happen is if anything changes in shopping cart, product catalog also would need to change, right? So maybe let's say we have few more teams also. There is this team also, and maybe there is one person. Okay, this person is working on payment service, right? So here this is also team or a dev, but yeah, he is again wanting to make some changes. So since he is making changes, everything is tightly coupled together. There will be changes which will be required in all the systems. So he has made some changes. He has added some changes or code change here. What would happen is, since things are tightly integrated, there would be some changes required here because they have to integrate and work together. And then maybe some changes are also required here in the product catalog, right? So he has to coordinate between all the members, right? So this guy has to coordinate with this. This guy also has to coordinate with these teams, right? So let me put here like this, right? So he has to do a lot of coordination, correct? And say at the same time, maybe these people are also doing some changes. Product catalog is also changing because yeah, there will be changes. When this is changing, you would need some other changes here in the shopping cart and maybe some other changes in the payment service as well. So these guys also need to communicate here. Let me use some other color. So let me use this color. No, this is this color. And this guy is also needing to communicate with this. And now, so since these people are changing, they have some new requirement which have to be fulfilled. They will also be talking to other because they have to tell about what are the changes, what other team has to do, because everything is tightly coupled. And so yeah, you see here, there is a lot of communication coordination required in this. People understand, appreciate? Are you able to appreciate this? Yes, right. So Ramesh, this is right. If all the modules are tightly coupled, right? And code base, you have a code base, which is usually a single code base, right? You may have multiple code bases also because you have modules, but yes, you may build the entire system together. Basically, why I would suggest that yes, when all the components are built, you build everything together, right? And then you deploy it maybe in single server or multiple servers, but you deploy it as a single unit, right? Together it gets deployed. So this is the difference between, this is actually monolithic architecture. Basically, you can think of that the system, when I'm talking about, say, a server, this is a system. See, everything is a single system. It may be different servers. For example, database may be a different server. You are creating tables, which is in a different server. Maybe you have multiple server. One server is web application server, where you have the business or logic running. Maybe you may have other servers, but these servers are placed together so that the components can talk to each other. And maybe you have a web server also, they may be running, but everyone knows about. So basically what is here important is one component knows about the architecture of other component, because product catalog has a code to interact with shopping cart. So that means product catalog knows that there is something called shopping cart. And if some changes are there in shopping cart, there would be changes required here also, because there is, as I said here, there is version 1, right? So let's say version 1, right? So that what actually it means, if I'm running version 1.0, right? Let's say call this product catalog 1.0, right? So I have this, and maybe there is some other version here, shopping cart version, right? So there is no guarantee of backward compatibility here, because if suppose this is say 1.2 or there is some version, you will always require that these versions are compatible, right? Because if you change something and there could be version mismatch, and then definitely you have to update the other components as well. So is this clear what is monolithic architecture, right? So
Yes.
basically you have a single system. It may be multi-layer architecture, but every system, every module can talk with other module. They know the address, they are tightly integrated. This is about monolithic system. So when you make a modification in one component, what it means, you have to modify all the components, right? Now, there could be other problem here. Since everything is deployed as a single unit, you may want the product catalog. So if you see here, if you have users, say mobile users, right? Maybe there are many users, let me draw there more users. So here, say this is mobile of user 1, this is mobile of user 2 and user 3. So when people are searching for product, they may search. So here more people will be searching for products, right? Let me draw these lines. Yes. So when you see here, more people will definitely search for products. Out of this, maybe only few of them will like the item and they will actually purchase, right? So basically, let's assume that whoever is searching an item, only 1/3 of people are purchasing an item. Yes. So maybe one person is only purchasing, rest other people are just browsing, and only one gets purchased. One item, one person purchases it, right? So what does it mean? If suppose there are 3 million users, so there will be 3 million requests to the product catalog, but only 1 million requests to the shopping cart. Yes. Clear? Now, so what should be the, say, assume one system can serve 1 million user. Let's assume one server instance can handle load of 1 million users. So how many systems will you use? Will you use 3 instances or will you use 1 instance? Right. So let me write here. So 3 million users are making a call to product catalog. Basically assume they are searching for, say, iPhone 14, right? So they are browsing the details, right? Out of 3 million users, 1 million users, they like the iPhone 14 and they decided to add it to shopping cart, right? So generally this is the traffic which you are expecting. And here one server can process, let's say, 1 million users, right? User requests to be. So how many systems or instances, to be more specific, would you need, right? Option A, 1 instance, B, 3 instance, C, 4 instance, and D, right? Okay, so what do you think?
I will go for 4 because if any of the 3 fail, one will be useful, right?
Okay, sure. But see here, yeah, here you see, shopping cart has only 1 million users. Right, so you need 1 or 2 instance for shopping cart, right? Say, let's assume this is reliable, is 100% reliable. There is no crashing here possible. So if we don't worry about that unreliability, and that means, yeah, maybe internally that is taken care of. Maybe when I'm talking about one system, one instance, it is combination of 2 instance. One is active, passive, or yeah, you have a backup instance also. So in that case, yes, how many you will go for? Right? See, you cannot individually scale it. You will need to go with maximum load for all the systems, right? Since modules are tightly integrated, so what will happen is you would need 3 instances, right? Maybe 4 also if you want to have some additional instances, because you may say that, okay, maybe on some discount season, you may get more users, right? So that is also fine, but at least 3 instances you would need, right? But yes, if you see shopping cart is being used by only 1 million user. And let's assume out of all these, if suppose there is some complaint, they will call customer support. Right? And after 1 million, only 1 or maybe 1,000 users, right? We go to customer support, right? Maybe they have to return item, or they got a defective item, or they have some issue with the payment, etc. So here is still you see that you will need to have very powerful instance, because product catalog is being used by many users. But customer service, even if it's not used by many users, but still, since everything is tightly coupled and is deployed as a single unit, you cannot ignore it, right? Because what actually happens if you build a system which does not have, say, customer support module, it will not work, because it will give missing component, or some compilation error will come, right? If you just do not put this customer service module into any system, right? So that is the problem with this monolithic architecture. So now, how to solve this problem, right? So what is the solution for this problem is the microservices architecture. Now, let me use another color. Yeah, this is microservices architecture, which will be the main topic for today, right? So what we do here in microservices architecture, we'll take the client, right? So again, you have a mobile, same application, we'll redesign it so that we have a microservice architecture and we can solve this problem. So what we'll do is we will have few systems here, separate systems. Instead of having single system, we'll take 4 different systems. Let me, yeah, move this here, so that I have the space for other systems. And this here, and let me get another one, right? So here. So first one is, say, product catalog. Then we have here, say, shopping cart, right? So then we have payment service, again, same modules, right? And then customer support. Yes. Right. Now, what we have done is we have given them different databases also. Maybe we can give them different databases. Right. Yes. So the code here is deployed separately. Right. So here, let's say this code is here. And let's say some other code is here. Yeah. And some other code here. Right. So these are, so basically here you have different, these are almost like different services or different applications altogether. Right. So now what will happen is when you're calling, basically you're calling product catalog, this system can scale by itself, right? So this is one server and this is another server. They are not tightly integrated, right? But then you will ask, how will they communicate, right? So we'll come to that. Basically, these are systems and they are different systems. And the way they communicate is they make a web service call, right? So there is some, how to depict some web service call, let's say, yeah. Basically what they do is when this call wants to call this guy, it makes a web service call, right? And this one, they want to communicate with this, they make a web service call, right? Like this, whichever module wants to communicate with other. So there is a web service call, right? And all these are different systems together. So basically you don't have a single application, you have set of services, and these services are small services. That's why they are called microservices, right? Now, so you know that yes, there will be many users who will be first browsing through product catalog, right? So you can create here multiple instances, right? So I can have one more instance here, one more instance here, and so on, right? And you know that, okay, very few instances are needed for shopping cart. So you can say, okay, I'll just have 2 instances here. And even very lesser are there. Maybe you may choose a powerful server also here. You may choose a less powerful server here and maybe even lesser powerful server in the customer support, right? So this way you have full flexibility of how many server instances to use in different components. So this is about my microservices, right? Everything is communicating with web services. Now the other advantage is the teams. Teams need not have to worry about changing anything in the payment service. They only need to worry about that the web service should work, right? So if there is any change, they'll be able to do this change without any problem, right? So one team can work here and this team can also work in this particular module. They don't have to worry about, yeah, maybe they have to worry very less when they are changing the web service, then only they have to worry. But internally they can make any changes, they can change the algorithm, etc. They can fix the bug and they can keep deploying their code here without making any changes to the other components, right? So you have basically multiple code bases or multiple deployments and everything can happen independently, right? So this solves the challenge. Clear? Yes, so both are scalable. This can also handle 3 million users. This can also handle this 3 million users, but these are two different approaches. In the first approach, the problem which we had in Monolith is, let's draw a kind of a table, right? So let me get a table. Okay.
Tarun, sorry to interrupt.
Yes.
I have one question actually. related with the message broker. I mean, you have explained the microservices architecture, right?
Yes.
In this architecture, I mean, I have just doubt. Is there any purpose needed for message broker? I mean, what purpose we are going for message broker or Kafka in this kind of
Yes, we'll come to that. We'll come to that. Yeah,
Yes,
we
yes,
are
yes.
building towards that. So
Yes.
I'll cover this later.
Yes.
Don't worry. Yes,
Okay.
you will understand it.
Okay.
Yes. Great, great. Awesome. Nice that I make a note of this question so that I can cover it later. Right. So yes, let me get a table. Here, let's say this is the table. Yeah. So first thing is here you have microservices, right? Let me expand this part. And then you have here monolith architecture, right? So monolithic architecture.
Sir, I have a doubt here.
Yes.
In this architecture, if the model or any schema is common between two components, do we duplicate the model in multiple
Yes.
code bases?
Yes, absolutely. Yeah.
Then if there is any change, we have to make multiple places.
Not necessary, right? You may have, then it will differ, right? Say, for example, let's say there is a table. Let me come with that also. Yeah, let's say we have a table. Here that's called customer table, right? Let's say there is a customer table. For this guy, for this team is product catalog team, right? So customer table will contain maybe ID of customer, name, age, right? Maybe address, etc. Right? Same in the payment service, you also have a customer table. So they designed it like this, right? And then maybe this guy may need, say, credit card number, credit card details. So you have here, you may make a change. Tomorrow you decide that, okay, I will also need an email address here. So you will add email here. You may not add it here. So now see, initially it may start same, but they can make independent changes because what needs to talk to this is only this component. What needs to talk to this is this component. So changes can be made individually, but this point is good that you will have redundancy. Same customer table is there in multiple places, right? Maybe this is in this database and in this database as well, right? See, if you change here, you did not have to change here because then basically you have a different schema. So this becomes your payment service dot customer table. This becomes basically your product catalog dot customer table, right? So basically these you can treat as like different tables itself, although the purpose is same, but they can be different. They need not have to change.
So will there be any shared databases for across these components, across these servers?
You may have a shared database also. Sometimes you may have shared database. Okay, that also be there. That can also be there. See, there is nothing which is perfect microservices. There could be a mix, hybrid kind of model also, where you may have maybe say tomorrow, there is payment service, you also try to make another service which can deal with, say, now there is something called pay later, right? Buy now and pay later. So So you may create another service here, but then you are in a hurry. So you feel, okay, that this service can also talk to the same database, right? So you may kind of put another service here also, right? So which is altogether a separate service, but yes, for time being, you have created here. Maybe once this grow, you may decide to move it to another microservice, or you may keep it like that only, right? But yes, if you keep doing that, then you are making something like a monolith again here, right? This part will become monolith. So you have to divide, but yes, if you divide too many times, what is the problem in that case?
Duplicate.
Yeah, duplication is there, but other problem is also there, right? Which could be related to performance. Because if you see here, all these calls are network call, web services call, right? Network call. This is local call. You are just calling something which is there in the single instance itself. But here you are calling across instances, and to enable any feature, you will have multiple network hops, right? So this is making very complicated, right? This is making this very low performing, and this is also, if you have more services, then you will have problems, correct, with respect to performance because of many network hops. Got it? What could be other problems, right? So this is what we were putting the differences. Right, so let me make it here a table. So let's talk about if there is a large team, right? For teams to work together, microservices basically easy to develop for large teams, right? Because they can independently. So basically, yeah, I could say better we say that different teams can work independently in microservices, right? So that's the basic advantage. Yes, but in case of let me just clear this. Yes, so different teams can work independently here. Yes, so here a lot of coordination is required. Right. Initially, this is simple, right? Because you need one system, right? It is also less costly, right? Because in microservices, you have to set up so many databases, right? So many individual components, not only just the databases, there will be many components which will be there inside. Yeah, so which would be, there could be load balancers, you need multiple API gateway, you need a lot of different kind of system components and many system components separately. You need to install here database. You may install here another database, another base. So you need a lot of database service, right? So it could have a lot of overhead also, right? And complex and costly as well, right? So this is about microservices. Now let's talk about testing.
One
Which is
practical
easy.
example, I mean, practical example of drawback I can give.
Pardon? Yeah.
Practical example of this drawback in microservices. Like debugging is quite.
Yes, absolutely. Right. So coming. So now we talked about teams, right? Then we talked about development, costly and all. Then let's talk about here. We'll talk about from every perspective. debugging, etc. Right? So let's talk about testing first, then we'll talk about other features also. Testing of microservices, easy or complex?
Easy.
Right? See, now if you apply divide and conquer strategy, so you only need to test one component, right? Because if you make a change here in product catalog, you may not make changes in other components. So you just need to check test product catalog. But in this, since changes have to be made and everything is tightly coupled, so always you will be changing at multiple places and involving multiple teams. Sometimes some team members, they will be changing multiple components also, right? So here there is no clear separation. If you see here, basically what it becomes is all the components are basically, there's no separation. Sometimes there may be some overlap also, because you can't say this is payment service, this is shopping cart service. So ideally, this is what monolithic architecture will look like. Basically, there will be a lot of overlap between components, and these components are not having clear boundaries. That's what I mean by this, right? So it becomes very complex to test it, because whenever you make any change in product catalog, you have to change everything, because everything is tightly coupled. And when you test, you have to test again everything, because you have made changes in all the modules. So testing become here. So here, first part is, this is easy, right? So here I'm saying easy testing, right? Right? Reason why it's easy, because you can divide and conquer. But here, in case of monolithic, testing is more complex, or I would say testing effort is more, right? Requires more effort for testing. Correct? Now, the other thing is, let's talk about deployment, right? Again, easy because of divide and conquer, right? But yes, creating the system landscape is complex, right? So you should understand that, yes, maybe the system architecture is complex. Overall, there is a complexity, right? So here I would say architecture, right? So architecture is complex, but deployment is easy if you consider that as single systems, you have to deploy each microservices. But if I ask you deploy the entire shopping cart application, then it becomes very difficult, right? So easy per component, but total deployment is very hard, right? Because you have to do everything, right? Maybe no one knows here how to deploy the entire system, because every team is working individually on their microservices. So they were able to deploy it in production, because one time every team member put effort. But yeah, if you ask tomorrow that again someone do this, you need again a lot of people to do that. So here deployment is complex for whole system, but individually to test any change, test any release, it is easy, because the components are small and they are not tightly coupled. In the other side, in monolith, so deployment for a whole system is easier, right, than microservices. But for any change, overall it is complex, right? So deployment process is complex. Great. Getting this point? right? Complex. And deployment is time consuming also.
Tarun, deployment process is complex per component in the monolithic, correct?
No, in monolith, there is nothing called component, right? You
Oh.
have always the entire system. You cannot deploy it per component because, as I said, any module, if it is missing, the application will crash, break. There is tight coupling between everything. So per component, you cannot deploy. You always have to deploy overall thing. And that definitely is complex, right? But overall, yeah, you just have to do it in one system. So I would say it is easier. So whole as a whole, right here, note down this point. As a whole, it is easier, but the process could be complex and time consuming because for small changes. Right? You make a small change in one module, you have to deploy the whole system. Here you make a small change, you just deploy in your microservice in which you make the change. So that is the difference. Got it?
Yes, Tarun.
Debugging is complex here because if some issue is coming, because there is so many web services call, you have to trace and you have to figure out, it's very complicated sometimes to figure out where the problem has happened, right? Because if you see the debugging, a mobile app is not working, some probably one icon is not displayed properly, right? So assume there is something wrong here, right? So if something is wrong here, now you have to figure out, okay, is it problem in the product catalog? Maybe, yeah, it is, because maybe this is some item which is getting displayed, but image is not coming. But here you say, okay, maybe the price is not coming and that's why. So price is coming from some other module, and yeah, there it could be multiple web services call involved. So debugging becomes complex because you have to do debugging, remote debugging. Basically, you have to do always remote debugging. Here you have to do always local debugging, right? So here, because of remote debugging, right? Remote debugging is very complex. Here it is local debugging, which is easier, right? Right. So this is about monolith and microservices architecture. So basically, yeah, you have modular architecture. So no, this is almost as good as you have everything in one package, right? But you may have some modules, but these modules are again not that clear with clear boundary. But here, definitely they are in different systems and they can be run independently. You can just run the product catalog service without having any other components, right? So this gives you more flexibility also. Tomorrow you can completely replace this customer support and you may buy some other customer support application, do some acquisition, get some microservices, connect this to this new customer support component, right? So you have more flexibility here. Something new comes, you can just integrate also easily, and you can replace anything also very easily, right? You say, okay, I don't want now this, and I got something new here. So that is also possible with this kind of architecture.
One more advantage could be it's like we can use different technology for each services.
Yes, yes, absolutely, absolutely. Yeah, you can use different, for example, you may use here, say MySQL, because this team like this database, maybe this team is working in Java. They can choose this, right? This team, they may want, say, MongoDB. They may want to use Node.js. Yes, they can do it. No problem. Because what they need to communicate is using web service calls only, right? But here it's not possible. Here you cannot call JavaScript code from Java unless you have some standard, right? Like web service calls. So you cannot call. So you have to have every code in the same language and same technology, and database only you have to choose one because there's only central database, right? So maybe you have to choose. If you have Oracle, so it's very hard to change because the entire application would need to go changes to change your database, right? Now, so not only it's easy to change, say assume tomorrow some new technology comes, right? Say now, after some time, they feel now there is something new in the market. Say, let's say DynamoDB, right? They'll make the change. The team can do change because yes, only this component needs to change, right? So the changing the technology is also easy, right? Some more differences I'll tell you. So yeah, you can say here this clear boundaries, right? And whereas here you don't have clear boundaries, you know clear boundaries, right? I can give you so many differences. Here, how about latency? High, right? Because everything is web service call. So this will be slow response time, right? Is slow. Here is low latency, high or is fast, right? Performance is better, fast performance. Because everything is local call, right? So if you have something like stock market application, right? Zerodha, that kind of application, because here every second, every millisecond, prices are changes for stocks. And if you miss out, then you may lose money, lot of money. If people are playing in crores of money, then this may become not good application if there is low performance, slow performance. But something like e-commerce application, if there is few milliseconds of delay, no problem, right? But it is a problem in stock market because every millisecond price is changing. So here you can prefer monolith. In some scenario, you may prefer monolith, but yes, in microservices, you get other benefits. So yes, so communication, because you should understand that communication is here. RESTful APIs is very common, but yes, basically you have web services. And here is your function calls, right? Could be remote calls or could be local calls, but yes, it is very fast. Debugging easy, difficult, we discussed only, right? So monolith is easy, and this is maybe I should say difficult here, right? Complex means. So same thing is logging is complex. So there's something called logging and tracing, which is very important, right? For any application, because this helps in debugging. That becomes complex here because what request it is, you may lose the context, right? Here it is simple, right? How about Yeah, see, deployment is easy and fast, right? Deployment is easy and fast here in monolith. Easy per component, but complex overall. Total deployment is very hard. I would say here, complex, right? Now, scalability. Let's talk about other stuff. Scalability, right? Which is what we discussed. This is easy here, right? Because assume there is a new iPhone, right, in the market. So you are expecting millions of requests, right? So you will scale this one. You will scale some services. Maybe you may not scale all the services. So it is easier. But this is harder. Scaling is harder. And there is, because you have to scale the entire system, right? So easy because, so I would say easy and flexible. And we are talking about horizontal scaling, right? Vertical scaling is easy. You just buy a bigger server and deploy, right? So vertical scaling is nothing. Horizontal scaling is what we are talking about. You understand, no? What is difference between horizontal and vertical scaling? I covered it in our first class, right? In very beginning. Horizontal scaling is adding more servers. Vertical scaling is by adding powerful machines, right? So there's two ways to scale. I may buy the latest hardware, which is more powerful, but there is always a limit to that. But in horizontal scaling, you can buy more number of servers. Maybe they are not that powerful, but they are cheaper. They could be cheaper. And there is no limit because you can keep adding more and more servers. Right? So this is about various differences. So maintainability is easy in case of microservice. Right? And independent development, we already talked about, right? Independent development is there. So yes, we'll discuss more about these things later once we will discuss some case study on this, right? But hope you guys understood now what is microservice and what is monolith, right? Now, these web services call, there are multiple technologies which can be used. Anyone who will tell me what is REST? What is REST? So let's discuss that because this is another important topic. Now you guys know what is microservice. So let me talk about what is REST. Anyone knows the full form?
Representation of
Representation state transfers.
Right? Representational state transfer. Yes. So basically this is a architecture style. And for building web services. So what you use here is mostly you use HTTP protocol, right? HTTP is an application level protocol. It is a text-based protocol, right? Because you have request which is like get, post, put, delete, right? So basically, I may have a API. Say, for example, let me call my .store.com. There is a site, right? When I say product and say one item number 1, right? And I say get, this means I'll get the detail of this product item, right? So maybe ID 1, then name iPhone, right? 14, right? And then description, right? You may have some description, color, many properties, price, right? So maybe 150, right? So this is what your response will be. So color, maybe. Yeah, correct. So this could be your response. When you make a call here, this is your request. So let me write this request. Right. So here, this is your request and this is your response. Right. So this is the read. Basically, operation is called, this operation is the read operation. Right. So
so the medium of this communication will be through message queues, right?
I'm coming. No need. It can be directly through browser, server, right? Client server communication, direct. No problem. No need to use message queue, right here. You attended the payment gateway class.
I missed that last session, sir.
Okay,
I think that information was
right. So basically, there is something called, we will be covering. But yes, since you are curious, I'll talk. There is about event-driven architecture. Right. In this, you will use message broker or message queue. Right. This is, or it is also called enterprise service bus. So there are many names, but the functionality is same. This is message broker, message queue. Will be covering it, right? But yes, first we are covering REST. REST can be direct peer-to-peer. It could be server to server, client server communications. Right? Any kind of communication could be. Without message broker also, you can have RESTful web service. So this is about read. Right. So same thing is for post. Let me write how to create a new product. Right. So what you do is you post and you post type of the request. This is what? This is the type, request type. Yeah, when I say read, get, when we say get and all, this is type. Right. So let me. So this is the type. Yeah. So when I say post, so I may just give the request my.store.com products. Now see here, I can't give the product ID because the product is not created. System will give the, but I need to also give parameters. So this is the body of request. In the body, I may give that, give me name is say iPhone 15, new item, new product which is getting launched. So I'm making this description. I'll add colors, right? Multiple colors could also be there. So there could be an array. Maybe there's new colors which are coming in this, right? Price, right? So right? So whatever. Yeah. So when I give this request, this is my request. So so yeah, this is my request overall. Right. So this is my write request. Update request will also be same. The only difference will be this will be put. Right. So the type of the request will be put. Right. And you have to give the body because you have to give the new fields because maybe you have changed the price. So you'll have the entire body here. Input, right? And this is this one I will say is create, and this is your put request, and you give the entire response again, the new, but maybe price has changed. That means there is some discount available. So the price has changed to some other value. So you have to give this request, and here you will have, say, update. Yes. Delete request is same as this. Here, when you create, you may just get 200. Okay. The response is basically just 200 okay or success, right? Creation is successful, no request because you know no further data is required here. Same is the case here. In update also, you may just have the success request response, right? In case there is some error, maybe your data is invalid, then you will get the error, right? If server is down, some other error will come, 500 error codes may come. So this is about REST API, right? So this type of calling where you put JSON data and you use get, post, put, delete. You may use other data format also. You may use XML also. You know, all of you know what is XML?
Yeah.
Right? Great. See, XML is you have some tags, right? So you can have product. And then you may have more fields here. ID, you may have a closing tag and one, and yeah, like that. You'll have all the tags, right? Right. So just and then you'll close the product tag, right? So something like this is XML. So you may use XML also, but yes, basically you may have some format here. Dot 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 means many tags, many fields could be there here. So XML is also possible. See, this is programming language independent. REST is, you can call the REST service via JavaScript, Java, C#, Python, anything will work because this data format XML or JSON. So this is about REST, right? Clear?
Yes,
Okay.
yes, sir. Okay.
Good. Yes.
I have one question regarding put and post.
Yes.
So practically put will do the same as post, and like we can also create an object with
Yes.
put. So I was asked in an interview regarding
Yes. This is a very important question about put versus post, right? There is slight difference. See, updates are something which is, we call it idempotent. Yes. So important thing you should know is idempotency. idempotency means if the same operation you perform multiple times, right? If the impact is same, then it is called idempotent, right? If same operation you perform multiple times, if the impact is different, then it is not idempotent. So when I'm calling post multiple times, right, what is happening? Multiple products will get created. Yes. Input, you also have to specify the product ID. So yes, this is one important thing, because input, you know which item to modify, right? You are updating that. So here you will put the product ID as well, right? So basically here, not here, here. And if I call this update multiple times, same item is getting updated again and again with the same values. So there is no difference at all. So in browsers, when you have post request, right? And if you try to resubmit again, you get a pop-up that this will trigger another request, right? So if you are making payment, or if you are clicking double times the order button, what will happen? 2 orders will be placed, right? But yeah, here if you use post, browser will detect that yes, you are refreshing. Yeah, that is also possible, right? If you are just refreshing the page and there is a post request, again 2 orders will get created, but browser will display a pop-up saying that you will be sending a request again. Are you sure you want to do it deliberately? So if you say yes, then only it sends the another request. So that feature you get from the framework when you use post. So use always for create post, use always put for this. Got this?
Yeah.
Use put for update because that is idempotent, right? Because what will happen is new row is created when you do post, right? Input, if the same row is there, only the data is updated. And it becomes very important that in a fault tolerant system, you use put, because if what will happen in idempotency, if some request fails, you can retry it. Yeah.
I have a doubt here. Oh, actually, there is a create product car only, but mistakenly, if I use get type, then will that work out or it will?
Get will all see, this is all semantic. You can do anything with any request. But this is the best practice. This is a REST. As per REST standard, you should do get for reading. It will work. You may do create also, because see, basically behind the scene, you have a code which is receiving this request and it is taking some action. So that code from code, you can write here also, creating some new table also, right? Creating some row and creating new product also. But usually you don't do that, because as per get request, this is what you are supposed to do. Rest is a architecture style. It is a style because you want to follow standard convention, because otherwise it will be difficult for someone to understand it. Correct? Code will become non-maintainable, difficult to understand. Right? So you can do with any request whatever you want. You can do multiple operations also, but as per REST is structure, you have to do like this.
Thanks.
right. So now next thing is rest we understood. Now we were talking about scalability. Yeah, I would say that, see, now scalability, what I told you is, again, I am just repeating. I told you that there is a, assume this is the client. Nowadays, everyone is using mobile. Mostly we browse application using mobile app. So I'm just drawing mobile as a client, but could be browser client also. Assume this is your product catalog. Right. When you make a request, maybe you are reading that product details. You want to get product details of iPhone 14, right? This details, you will get this JSON here. When you make a request, server will return this, right? And your UI knows how to display this. So it will display this nicely in your mobile, the product details. Maybe here you will have product image URL also. So you will get the image of the iPhone also. Now you can buy that. But what I said is there are millions of users who will be accessing it. So I also said what you will do, you will have multiple instances, right? So this will help to distribute the traffic. So some traffic can go to this server and some traffic can go to the other server. So this way the server will be having the load evenly distributed. Correct? But who does it? Is that the UI does it? That randomly it will pick one server? Or what if this server crashes? Right? So assume this server has crashed. So now, since this is crashed and this is in good state, right? That screen. All the requests should go here. Right? Maybe some performance lag will be there because the load of the server will increase, but still your application will be working, right? But yes, you should not make the call here because this will result in error because this product server has crashed. Maybe hardware failure or some logical bug because of which, or anything, any failure could happen, right? So how do you distribute the traffic? So what we do is I shared that there's something called load balancer, right? So load balancer, yeah, I got this. This is the load balancer. So basically what you do is these applications, they will call the load balancer and load balancer knows where to distribute the traffic. Right? If something is down, it will not distribute the traffic to that server. So that logic you can keep in client also, but that is bad because you will have to modify the changes as and when you are adding more servers, right? So you can't do it in the client side, you have to do it in the backend side only or in the load balancer. This is clear, load balancing, right? We discussed there are various strategies of load balancing also. What are the strategies? Just revise. Tell me, what are the load balancing strategies?
Round robin, weighted round robin,
Awesome.
least responsive.
One sticky.
Yes, absolutely right. So, yes, what else? Least response time,
Responsive.
And sticky.
right? And yeah, you may have say IP hashing, sticky, right? You can have say a sticky session, right? So various ways are there, right? Maybe more are there because you may have many combinations of these as well, right? So these are various commonly used load balancing strategies. Now I want to discuss one more component, which is called which is like a load balancer also. Sometimes it is replacing the load balancer. This is called API gateway. Right, let me get the API gateway.
But API gateway would be routing the request to its original endpoint.
Yes, yes, absolutely. Right. So let's say API gateway. Okay, I got so many gateway. Something is, I'm getting, yeah, API gateway. I got it. Right. So yeah, here API gateway. Awesome. Great. Yes. API gateway is, first thing, it will be doing load balancing. It can do the load balancing if there is. See, but yes, we definitely need that. Yes, but yeah, you made a very good point that it will be making the routing also, right? So yes, we discussed only product service here. This is for catalog. But yes, you will have other services also because we have the shopping cart also. Yes. So there may be one more request, which is, say, and we'll make one more request, get, right? And then we say shopping cart. Right? If I call this, right, and I say my.store.com or amazon.com or whatever, this is my host and this is my second part, shopping cart. Maybe then I give here user ID, right? Maybe user ID for me is 1000. So then I see my shopping cart. In shopping cart, you may have items, and within items, you may have, yeah, maybe ID, product ID, say product 1, product 2. So I am purchasing both iPhone 14, iPhone 15. So you just have the IDs, right? Something like this is, just assume you have this REST API for getting the shopping cart. So now what you need is also shopping cart servers. Right, so let's say this is shopping cart server. Let me draw it again. Right, so one here. I'm drawing again now, one over the other, because we have so many microservices, right? But yes, this is shopping cart. So basically, maybe first user is calling this URL, get product 1. Right? Second user is calling this second thing. Right? So now load balancer cannot determine that, yes, this request has to go to shopping cart and this request has to go to product catalog. But API gateway is something which can determine even that, and it can do the routing of the request to the appropriate server, right? So here, API gateway will see this part. This is different. This part is shopping cart, and it will be configured in such a way that if product is there, you go to this particular server. If shopping cart is there, you go to this server. And even within the shopping cart servers and product catalog servers, do the load balancing. So that can also be done. Right? So this is about API gateway. So API gateway is load balancer plus routing. This is API gateway. right?
Doubt here. The product get like a service want to call shopping cart service, again it will get to API gateway, then call.
Yes, yes, yes. Right. See, now this also simplifies your client code. Because otherwise in the client code, you would have to call, say, for example, let's say this server is having IP address 10.250.1.1, right? This is the IP address. This has an IP address 10 dot maybe 151.2.1. So basically then I have to make my client call different endpoints, right? Maybe this could be domain name also, some different domain names also maybe. So instead of making calls to different domains and host names, here I can always call in the client. I will always have one endpoint, but internally it will be routed to multiple server. This is how you do. This pattern is called API gateway pattern. Correct? You guys also talked about that you will have a lot of redundancy here, right? Redundancy in the database, redundancy in many features. For example, now assume now other part is very important. You can only call the list of products after you are successfully authenticated. Let's assume this is the case. Yeah. So now question from Ramesh. Let me take that. In Monolithic, can we use load balancer? Yes, you can use load balancer in Monolithic also, because this entire you will have behind the load balancer, you may have the multiple instances of it, and you may add a load balancer here also. Right? Let me get a load balancer here. This is a better load balancer for me. Okay, they have not shown here a load balancer. Okay, yeah, there are more things here. So so many components are there here. Okay, never mind. We'll use this icon. This is the load balancer. So you may have a load balancer. So you make a call here to load balancer, and load balancer can route this traffic to whichever instance is up and running. It can distribute the traffic. Yes, so we were discussing about authentication. Let's assume for product also you need authentication, and also for shopping cart also you need authentication. If the request is not authenticated, then it will not serve the request. It will show please authenticate. It will give an error message that unauthorized maybe. So you have to add this code here. You also have to add this code here. Right? So this is a lot of redundancy. In all the microservices, you need to add the code for authentication, right? So we'll add here the code for authentication. Assume this is the code for authentication. Let me call it by putting A here. So you need authentication everywhere, right? Because everywhere you have to ensure that unauthorized people are not accessing any service. Lot of redundancy, complication. In API gateway pattern, what you can do, I will implement the authentication in API gateway itself. Correct? This way, no need to have redundancy here. This problem is also solved. This is a microservice pattern. So now we will be discussing microservices pattern. And first pattern is API gateway, right? And feature is load balancing, routing, authentication. Correct? See, API gateway has so many features. We can count on fingers how many features are there. Authentication is just one example. I can give you more such examples. Right? Caching. Caching also is required for all the API calls, right? Because I have seen the product detail for iPhone 14, right? If you are also requesting, why to make a call to the server? Why not give you directly if I have the previous call? So let's do caching also here. See, right? Because in many services, you would need caching. Right? So in case that item is already here available, you may directly return here. It is so fast. Yes. API gateway can also prevent. Yeah, it can also act as a reverse proxy. Right? See, what was reverse proxy? We discussed in the second class. What was reverse proxy? Can anyone tell me? I have a client, right? No one recalling what is reverse proxy? I have a server, right? I would like to hide this server because if people know about this server, they may start hacking it. Yes. I want to hide it from the client. So what I can do is I can add here a reverse proxy. Whenever there is a call, it will come to reverse proxy. Reverse proxy will make the call to servers, right? This is another feature of API gateway. API gateway can also act as a reverse proxy. It can also act as a load balancer. We already saw. And yeah, reverse proxy also does the caching again, because API gateway can also do caching. Now, another question is, yeah, does anyone knows about rate limiting? What is rate limiting? Yes.
We can limit API call.
Yes, absolutely.
In a
Absolutely.
second.
Correct. Let's say there is some other mobile vendor, right? He sees, oh, iPhone is getting sold. Let me do something to prevent the sale of iPhone, right? This guy, what he can do? He can hire some hackers and tell them that just keep making faulty calls.
DDoS attacks, I think.
Yeah, DDoS attacks. So what these hackers will do, they will bombard product catalog with millions of requests to make it down, and then people will not be able to see the details of iPhone and they will not be able to purchase the iPhone. But yes, what reverse proxy can do, it can detect this. So what we can do, how to prevent this? we can rate limit, right? We can say only allow 100 calls per client, right? So by rate limiting, you restrict the number of calls. But yes, if you have DOS attack, DOS, this, yes, you should know on this term. DOS, right? DOS is denial of service attack. This is basically done by making fake requests, just overloading the server with fake requests so that the server becomes very slow and it crashes also. And this way they want to prevent servers from running smoothly. So this is there. But yes, there is also something called DDoS. Right. So DDoS, yeah, basically is very. So in denial of service, yeah, you will send the request from one client, from one computer. Maybe you will run a script which will make thousands and millions of requests, right? And in DDoS, DDoS is distributed denial of service attack. These are malicious attacks, right? These are hacker attacks on system. In distributed, you don't do this from one server, you do it from multiple servers so that you can fool the rate limiters. Rate limiters are thinking that yes, you are receiving these calls from real users, but it is not. It is the hackers who are running the script in multiple server, and this way they are making server crash by bombarding it, because they know they have the API gateway which will rate limit, right? Rate limit will prevent more number of calls from a single client, but it cannot detect calls from multiple clients. So how do you prevent that?
In a time limit between requests.
Pardon?
Time limit between requests.
Yeah, but requests are coming from different clients.
Okay.
Yes.
Maybe segregated gateways or something.
Yes. Yes. Right. So there are various ways. One way is, yes. Okay. But how do you achieve? Say one way is using API key, right? You may have a feature of API key. You would have seen in many places. In many APIs, right? When you call, you have to give some API key, right? Which could be some long string, right? Something like this. This could be an API key, which you have to send in the REST request. So unless I don't put this API key in the request in the REST response, right? So here, probably I will have to also add the API key also in this request, then only it will. And they can with API key track that yes, this is coming from same server, same client. And API key cannot be regenerated because they have used some algorithm, and they can verify whether this API key is valid or not. So a hacker will not be able to generate the API key, right? But yeah, maybe if he can pay a huge amount to generate multiple API key, or he may get somehow more number of API key. But yes, API key can help you in preventing denial of service attack, because you'll not be able to generate more API keys. But assume hacker also generates more API keys. Then what you can do is, generally people do, there are advanced softwares also available, which is basically firewalls, right? Firewalls can detect malicious activity, because in the backend they may be having a list of servers which are blacklisted, right? So assume they get to know, so they will have they will have a lot of capabilities. Firewalls will have a lot of capabilities. They may use a lot of other algorithms also, right? Machine learning also to detect all So yes, this is about how to prevent denial of service attack. But yes, we were discussing about that there are many features which are required in API gateway, and we have to code it in all the services. But with API gateway pattern, you can remove this redundancy, right? So authentication is done in microservices using various protocols, which could be OAuth, JWT, etc. So API gateway can have this complex authentication mechanism in place. It can have rate limiting it in place. It can have routing as well in place. It can also version the API. It can also do API management, right? Maybe it knows all the APIs which are available in the system, and it can show to users what all APIs are available. So a lot of features could be there in API gateway. So security features could also be there. Logging and monitoring also can be there in API gateway. Error handling can also be there in API gateway in case of, right? There is also something called course. Anyone knows about this? This is very common thing. Course, right?
Yeah, cross origin.
Yes, cross origin request, right? Sorry, cross origin resource sharing. Right, so this is course. So this is another special features which is implemented in all the servers. If the request is coming from some other domain, it will be denied by default, right? So for example, you have to allow everything for product catalog because many clients will be calling product catalog. But for payment service, right, or shopping cart service, you know that directly users may not be calling shopping cart, only product catalog will be calling shopping cart, right? Or few services will be calling shopping cart. Same could be with the payment gateway. So you restrict everyone, only allow particular domains to call this. So that is called cross origin request. So you basically create a whitelist, right? So there is something called blacklisting. Blacklisting is if I blacklist some server, that means if any request comes, I will ignore it. I will not process it. This is called blacklisting, right? Right. Whitelisting is if you have a list of some servers, only you process the request from only these servers. This is whitelist. Yes, so got the difference between whitelist and backlist, right? So if you have a whitelist, that means anything outside whitelist is not allowed. If you, so inclusion and exclusion, right? So in whitelist, everything is there, you include it, rest everything you ignore. In blacklist, you exclude whatever is in the blacklist, rest everything you allow, right? So this is about blacklisting and whitelisting. Other things which API gateway can do is there are a lot of protocols for making calls. So let me list all of these. See, you can search about it. Knowing this is not very difficult because there's so many different kind of formats. REST is one format, but REST could be slow because it is JSON. JSON is text-based format, so it could be slow. maybe some binary format would be more suitable to transfer certain message, right? So binary is very efficient format. So you may have something called BSON, right? Or you may have JSON, which could be text-based. But yes, there are various other approaches also, which is for handling the request. So let me share a list of that also. So there is something called gRPC. Right, so this is from Google. So there are a lot of different kinds of protocols.
Yeah, gRPC I think uses protobufs.
Yes, absolutely, absolutely. Right. So there are other format, because here what you have is you have to specify the metadata with the data, right? In JSON. Say, for example, this field is the name of the product. I'm specifying the metadata. This is the description. This is the color. This is the price. In gRPC, you do not describe the metadata. You just describe this is field 1, 2, 3, 4. And you send across the metadata only once, right? It's unknown to the client. And with every data, you just send the data with the column numbers. So that is another protocol. This is done by gRPC, is something which is done by Google, right? Protobuf,
GCP.
Facebook is from Facebook. Yeah. So there are various ways of doing REST APIs optimization. Basically, these are helping to improve the performance of REST APIs. So there are many such. So again, we need separate discussion for going through all these kind of formats. Not that important, but you should be aware that there is ways of optimizing it. There is also something called GraphQL. Right. So gRPC is there. You have protobuf. Protobuf is basically the format for the data, for sending data. gRPC is the protocol which uses protobuf. And then there is something called GraphQL. GraphQL is a standard for querying JSON, right? JSON data. So basically, this is another kind of protocol for making efficient REST APIs. So yes, what API gateway can also do is it can do protocol conversion. Maybe this server only communicate with one protocol. Your request is coming in one protocol. It can convert JSON into some other format, maybe XML format if server understands only XML format. So it can do protocol conversion also, transformation. So this is request transformation or protocol conversion. So a lot of features are there here in load balancers, reverse proxy. Reverse proxy can also do SSL termination. Yeah, this is last term I will be explaining here, because now this session is getting heavier. We are talking about a lot of terms, right? Now, can anyone tell what is SSL termination? Let me draw again something interesting so that you understand SSL termination. It's a very important concept, is very important in many applications. See, these things are very helpful in your daily job as well. It's important for interview, but it is also important in designing any application. Anyone who is a senior developer will be needing to know this. This is server, right? For security reason, you should send HTTPS, correct? Because if HTTP is there, someone can, because yeah, this request will be going through many places and some hacker may kind of look into this. So HTTPS is more secure. But the problem is it is slow, right? With security, you get the overhead because there will be encryption. So what you do is you have only HTTPS until API gateway. After this, you do HTTP calls, right? Because this is secure environment, right? Because this area maybe is a trusted zone, right? So you do HTTP here. And HTTPS from client to server. HTTPS, right? HTTPS is with encryption, certification, etc. Right? So where you terminate, it is you terminate in API gateway. So API gateway can take care of SSL termination. That means it will decrypt HTTPS request and it will send HTTP request to other servers. Again, it will be improving the performance. All are techniques to do performance optimization of your web services. So there are many features of API gateway. So this is API gateway patterns, right? So this is all I will cover today. In the next class, we'll discuss more patterns and it will include message broker also. So do attend the class, next class for message broker. And when I'll be covering a message broker pattern, I'll also be discussing in depth about Kafka and how to design a system using message broker. And I will also share what problem it solves. Right? But until now, everything clear? Today, what all topics we covered? Did you understood? Yes or no? Just type in.
Yes, yes.
Right? So any doubts are there, please ask me. And yes, we'll be covering more topics in the next class, which is about other microservices pattern. There are around 8 to 10 microservices pattern, which we'll be covering. So we covered API gateway today, load balancing, reverse proxy. Now you also understand. So when to use load balancer, now you know. When to use which kind of algorithm, that also you know, right? Which kind of load balancing algorithm, I mean, because this is very important thing you should know. And then when to use reverse proxy, when to use API gateway, these are also some of the important thing you should know. Good. Any questions for today's session? From content of today's session? If no questions, we can end this class. Right? Have a nice evening and then see you on next class on Thursday, where we'll cover more patterns, right? Which will include message broker and Kafka, right? Is it fine?
Yeah.
Yes,
Or you want to know something about message broker now, or you can wait, because we'll wait. Then I will tell you in detail, in depth, because today now we don't have the time to cover that in detail. But yes, definitely we'll cover it in detail so that you can use it and design various kind of system. But yes, you should know this term, event-driven architecture, right? This is the next stage of our architecture. And we will also cover orchestration, choreography, and message broker, how message broker helps and what problems it can solve.
Sir, Kafka and RabbitMQ are both are same or different?
Yeah, it's same purpose, different products. Right? RabbitMQ is a different product. It's a lightweight. Kafka is similar tool as RabbitMQ, but it was built by LinkedIn, and then the people who they started their own company. Now the company name is Confluent, right? That owns the Kafka product. So it's a different product. It is again a message broker or message queue. So both are message queue, but they are different products like MySQL, Postgres, Oracle. They are different products. Same way, RabbitMQ and Kafka are different products. But the purpose is they both can be used to achieve event-driven architecture. They both are message brokers, message queues.
Thank you, sir.
Great.
Yes, Victor, you can explain this detail in because in every interviews now they are asking this. I'm seeing they're asking if you are using Kafka or message queues or these things they are asking.
So you want what? We'll be covering it in detail in the next class. Today, you want anything? Any questions for today?
No.
Right, but yes, in the next class, I'll cover message queue next, right?
Yes, sir.
Yes, so let's discuss the next pattern as a message queue pattern. Today, you should understand API gateway pattern well. And in the next class, you will understand the other patterns, including message queue pattern.
Yes, okay.
Message queue or this pattern.
Okay, thanks.
Awesome. Because yeah, this basic was required to go further. So that's why I'm not covering Kafka or message queue first. First, I have to describe message microservices, then API gateway pattern, right? Before that, I covered load balancer, reverse proxy. Then I will cover message broker like Kafka. But yes, be assured that each and every topic will be covered in a very systematic and incremental manner so that you are able to understand everything very thoroughly and you can confidently answer these questions and you will get good amount of understanding. But yes, be regular and attend the sessions. This way you will be understanding, because today if someone is not attending, he attends the next class, he will not understand. He may not understand many things, right? Or you guys definitely will be understanding it in a much better way than others, right? So I enjoyed taking your class today, and thanks for interaction. See you in the next class.
Can you discuss one more thing about the reactive architecture and reactive system? Reactive microservices, there's a new term coined.
Yes. Reactive applications. Yes, we can cover that also, right? Simple, nothing very difficult. It is mostly like callback mechanism, but yes, we'll discuss reactive architecture also. Yes. Great. Awesome. But yes, that is not that important for interviews, right? Hardly anyone would have been asked about reactive, but yes, it should be good to know. And yes, I would suggest, yes, let's cover that. I am agreeing that this is something which is worth knowing, because yeah, maybe there are less chances, but still it can be asked in interviews. Good to know that.